Good evening, everyone. Am I audible?
Yes, ma'am.
Okay. Let's wait for 5 more minutes, then we will start the session.
Okay, ma'am.
So, was week 6 completed in last session?
Yes, ma'am.
Okay. So, since your week 7 deadline is on Wednesday, right? So, before Wednesday, only this session is there. So, today I will cover all the theory part of week 7 as well as we'll do the practice assignment. Okay. So, if I'm not able to take all your queries from activity questions as well, then you can just post them on Google Forum or Discourse. Okay.
Sure.
Yeah. Excuse me. Okay, so I think enough people have joined now. Let's start. I'll share my screen. 1 second. Is it visible?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
visible.
ma'am.
This is okay. You can read this, right?
Yes, ma'am.
Yes. Okay. So first of all, today, look, we don't have much time. Okay, only one class for all of week 7. So please, no time wasting today. Okay, and everyone will stay on mute while I'm explaining. So today we will start with dictionaries. Okay. So till now we have learned about what are lists, right? So just like lists, dictionaries are one more data structure. You can think of it as. So what is the difference? Does anyone know what are dictionaries before I start? Okay, first tell me what is a normally what do you know by a dictionary? A dictionary is where we look up words, right? So how
Yes,
are the entries present in a dictionary? Usually there is a word on the left hand side and on the right hand side there is the meaning of the word, correct? But
Key and
is there
yes,
value.
ma'am.
right key and value? So is there any word in your normal dictionary I'm talking about? Is there any word that is repeated?
No.
No. That means there is a unique entry for every word, right? But it
Yes,
can happen that two words have the same meaning, right? That can happen. That
yes,
there are
ma'am.
synonymous words. So similar concept is used here. But instead of words, here the key value pairs can be anything. Okay. So first difference between list and dictionary is what? In list, we only had values. In dictionary, we will have specific key value pairs. Again, in dictionaries, each key will be unique, but the values can be duplicates. Now, tell me, in list data structure, can I access any element I want directly or do I have to traverse the list for that?
Travel through
So
list. With the list.
So let's answer.
iterate from beginning to end.
You have to go from beginning to end using what? For each block, right? Okay. See, if this is my list, I have this list of numbers, let's say 5, 10, 15, 20, 25. Now, if I want to access this element 20, I cannot directly access it, right? I have to start from 5, then 10, then 15, then I'll reach 20. But in case of dictionary, what happens? You can directly access any element using its key. Okay. So let's say there is a dictionary which looks like this. These are key value pairs. Okay. A1, B2, C3, D4 looks like this. So if I want to access this element, this entire element, then I can just access it using this key D. Okay, we'll see how that happens. Look, in dictionary, each entry looks like this. If A is a key and the corresponding value is 1, then this is one entry of the dictionary. Now in list data structure, which bracket did we use to show an empty list? If L is an empty list, it is like this,
Square
right?
bracket.
Square bracket.
Yes. So if D is a dictionary, then we will do curly
Curly
braces.
bracket.
Yes. Okay. Now let's actually learn what are indices and everything. So a list gives a sequence of values. It can be anything. Can iterate through a list, but random access is not possible. In list, we always have to traverse from first to last. To get the value at position I need to start at the beginning and walk down I minus 1 steps. Right? That means I have to run a loop through the dictionary, through the list. A dictionary stores key value pairs. For instance, let's say I have a dictionary which has chemistry marks as value for each student as key. So let's say no two students have the same name. Okay, we have to assume that no two students have the same name, but they can have same chemistry marks. So for that, let's say I'm storing this key value pair in a dictionary D. So maybe there is some student called Rahul. So for them, it will look like if he scored say 60 in chemistry, then an entry will look like this. Okay, you can put this within inverted commas. Then any XYZ student and their chemistry marks. Like this, it will go. So as soon as you access Rahul, you can directly access any of the keys and it will give you the corresponding value associated with it. Similarly, one more example can be when we learn about the train data set, there it will become more clearer how it looks. So a train route can be a key. Okay, because every train route is unique. And the station, the source station from where the train is leaving. So more than one trains can have the same source station, that's not a problem. But the route itself has to be unique. So train route and source station can be one more key value pair. Okay. Now this example says present the key to extract the value takes the same time for all keys. That means you can access any key randomly and it will take the same amount of time to extract the value from it. Okay, any key. So if you have this dictionary that we said that it was storing key value pairs like student is to chemistry marks. So if that dictionary is say it is called chem marks, I'm calling this dictionary as chem marks. Okay. Now I want to find the chemistry marks of Rahul and I want to store that marks in this variable m. So I will write m equals to chem marks. In this square brackets, you have to mention the key. Okay. This will fetch, calling this will fetch the value, corresponding value stored against Rahul. Now see. So is the concept of dictionaries clear how it looks like?
Yes, ma'am.
Yes, ma'am.
Then we will do the pseudocode for dictionaries now. Okay. So at a raw level, sequence of key value pairs within braces. I mean, this is the most basic definition of a dictionary. If this is dictionary D or chem marks, whatever that was, each key value pair inside it looks like this. These are one elements of the dictionary. Okay. So Clarence, Rahul scored 92, Clarence scored 73. So if you write chem marks within brackets, Clarence, this will give you what? 73. Right. Okay. Empty dictionary, how do we write it? I already showed you. Empty, curly braces, open and close. Okay, now let's actually see the code. You can also assign values, right? So if I have a new key that I want to insert, let's say this is my chem marks dictionary. Now I have the value for 3 students here. Now maybe I want to add one more student. Let's say I want to add a value for Shreya. Okay. So this is what? This is a key. How will I add a value? I mean, how will I add this key value pair to this dictionary? I have to write chem marks, then write the key here. Within the brackets, write Shreya, and then you can assign the value to it. Maybe she scored 90. Okay. So after you do this, then if you check the dictionary, there should be one more key value pair here for Shreya is to 90. Okay. Okay. Now see, this is the pseudocode. So collect chemistry marks in a dictionary. So this is that same chem marks dictionary. It is just showing how we created it. So firstly, before you enter any keys or any new key value pairs in a dictionary, you must initialize the dictionary as an empty dictionary, right? So the first statement will be what? Chem marks empty dictionary. Okay, this is what? This is creating a new dictionary. Now, second step is what? You start a while loop. Now, we are using the scores dataset, obviously, since it is chemistry marks. So that's present in scores dataset. So I will iterate through every card in the dataset. Right. So while table 1 has more rows, that means while it has more cards, read the first card, X in table 1. Okay. Now let's say the whatever is the name present in this X card, I have to store that in the name variable. Okay. So name variable will store x.name. Marks variable will store what? The chemistry marks of the student in the X card. Now, after you have done this, now you can form the key value pair. So now you can assign this marks to this name by writing this statement. So in chem marks dictionary, name is now a key. And to that key, I have assigned the marks, corresponding marks code. Okay. So like this, I can go for every student and create one entry. Now we are assuming here that the names of students are all unique because keys cannot be duplicate in a dictionary. Okay. No duplicate keys. Now, how do we iterate through a dictionary? In a list, how do we iterate? We use a for each block, right? Like for each k in this list. So what will I write? What will be the corresponding statement for a dictionary? In dictionary, keys are everything. Okay. Keys will help you navigate. Keys will give you the corresponding values, everything. So there is a function called keys function. Okay, if I have a dictionary D and I write keys D, this will return me a list of all the keys present in dictionary D. Okay, so in our chem marks dictionary, if I wrote keys chem marks, this will give me what? This will give a list of names of student. So it can be anything that Rahul, XYZ, whatever it was. It will just give all the keys of that dictionary in a list format. Okay. So for each key in keys D, so basically we are traversing through a list only. Okay. But how are we getting the list? By using this keys function. So keys of any dictionary will return a list of all keys of that dictionary. Now you can use a for each block. So write for each k in keys D. Keys D is the list of keys. So you can do anything with that, right? So do something with dk. Dk is what? What will dk return? What is
The
k? K is
element of key, the value of the key.
right. So dk will give me what? Value of key k, right? Value associated with k.
The list of keys.
Okay. Now see, there is one example given. Compute average marks in chemistry. Now I want to find average. So chem marks is still the same dictionary having chemistry marks of each student corresponding to their name. Okay. So now I have two new variables. I have to take a total variable and a count variable, and I assign both of them 0. So for each k in keys of chem marks are what? Student names, right? So if I write keys chem marks, it will give me a list of what? Student names. Agreed? So
Yes, ma'am.
now within the curly braces, that is in the for each block, we are writing what? Total equals to total plus chem marks k. That means this total variable will keep on updating, and we will keep on storing the sum of all chemistry marks, right? We'll keep on storing the sum of all chemistry marks of students in this chem marks dictionary. So for every student, we will add their chemistry marks to the total variable. So at the end of execution, and count is doing what? Count is just every time you're picking a key from the keys list, it is adding one to the count. That means count is just maintaining a number of keys present in the dictionary. So at the end of execution, total will contain what? Total will contain sum of chemistry marks of all students in chem marks dictionary, and count will be number of keys in the chem marks dictionary. So just dividing total by count will give me the chem average. Is this code clear, everyone?
Yes, ma'am.
One second. Yeah. Now see. Now we saw that if I wrote keys of a dictionary, it will give me list of keys. Now, how do I know that a key is already present in a dictionary? How do I check that? So typical use of a dictionary is to accumulate values. Say there is a dictionary called runs. In this, I am storing every name of the cricketer as the key and the runs scored by them as the value. Okay. So runs Kohli will give me what? Runs scored by Virat Kohli. Okay. So each time we see an entry for Kohli, update his score. We'll see what this means. Let me get the code first. Yes. See. So Kohli can score a number of different runs in different matches, right? Our data set is what? It is runs from different matches. That means there are more than one scores against Kohli's name. Okay. So what will I do? Each time we see an entry for Kohli, update his score. So each time there is a score that we find in our data set against Kohli's name, we'll do in this runs dictionary, we'll update his score. Okay. That means we will keep on adding the scores for Kohli. So what will this part do? Let's say in the dictionary currently, there is this key value pair present for Kohli. Kohli is to, let's say 100. Maybe that's the first entry. Okay. That's the first score I found for Kohli. Now, further down, I see in my dataset that there are other scores against Kohli's name too. Maybe the next score is 80. Okay. So what will I do? Runs Kohli will give me what at this point? 100, right? So to update this, I will just add it, like with the new score, I will add this. So runs Kohli is 100 plus new score. That is this score. That is the next score that we saw. So you have to keep on updating this value of this key. That means at one point Kohli is to 100. It was present. Now after I found a second entry for Kohli, now it has updated. So now Kohli is what? After I have added, it will give me 180. Right. So what about the first score for Kohli? So create a new key and assign score. Okay. This is usually how we assign value to any new key. Okay. So in this line, what we are doing, we are adding the scores, all the scores that we can see. Each time we see an entry for Kohli, we update the score. That's fine. Now, what about the first score? Right. So for first score, we did not find any entry. Correct? So before I saw this 100, was there any entry for Kohli in my dictionary?
No.
No.
Yes, no.
No,
No, right?
ma'am.
So I have to create a key. Okay. How do I create a key? Just write the dictionary name within third brackets, write the key and assign it the score. Okay. But after this, when there is one more entry for Kohli, I can see, then how do I check whether that key is already present in my dictionary or not? So how do we know whether to create a fresh key or update an existing key? This is a problem. So for this, we have one more function called isKey function. Okay. Just like we had the keys function, which returned the list of keys of the dictionary, isKey function takes two parameters into account. One is the dictionary name and one is the key that you're searching for. This function will return true if this key, K, is already present in dictionary D. But if K is not a key of dictionary D, then it will return false. So if it returns false, then what do we know? That we have to create a new key value pair for this K, right? But if it returns true, that means K is already a key and I can just update the value. Is this clear? What isKey function is doing?
Yes, ma'am.
Anyone who doesn't understand? Look, I'll just take a small example. Let's say there is, in my dictionary, currently I have Kohli. Then I have, let's say for Rohit, I have 80. And Sky, I have 50. Okay. Now, in my data set, I have what runs from different matches. Now, while I'm going through my data set, let's say I find one more entry for Rohit in a separate match where he scored 50. Okay. So what will I do? isKey. At this point, if I use this function, isKey, this is my runs dictionary. I'm sorry, I should write this within curly braces. Yeah. So isKey runs, comma, Rohit. Tell me, what will this return? True or false?
True.
True, right? Because Rohit is already a key in this dictionary. So I can just update the score. Now, after this, okay, if I find one more entry for say, let's say I have one more entry for Dhoni, who scored 70. Okay. So if I just change the name here, instead of Rohit, if I search here, what will this return?
It will return
False.
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 Because there's no entry yet for this key. So I will create a key. Right. If I want to add this to the runs dictionary, then I have to write runs Dhoni and then assign it the value this. Okay.
Ma'am, so every second time we need to use this function is key.
isKey no, I'm just telling you what this function does. Okay. If you ever want to know that a key is a member of a dictionary or not, whether it is already present in a dictionary or not, then you use this function. Okay.
Okay.
And if it returns false, and then you know that there is no such key present, and you can add the key value pair in the dictionary using this statement. Yeah. Now see, typical usage is what? See, if is key runs Kohli, that means this part, what we just saw is that I am checking whether Kohli is already a key for runs dictionary. Okay. If it is true, then it is updating the score. That is just adding the next score of Kohli. Else part is doing what? That means when will it come to else? When this returns false? Right. This will return false when Kohli is not a key in runs dictionary. So if it doesn't, if it's not a key, then I have to create a key value pair. I have to create this new entry for Kohli. Okay, so every time this returns false, you can create a new key value pair for that. Now, see, checking for a key. Implementing is key, dictionary, and this is the key. But always maintain this order, okay? Don't write the key first and the dictionary later. You have to write the dictionary name first, then the key you're searching for. Okay. Now there is a procedure given here. What is the is key function actually? I mean, how does it work? Okay, that is what it is showing here. See, procedure is key dk. D is dictionary, key is the key that I'm searching for. K is the key. So found is a variable first, which is assigned the value false. Okay. Now for each key in keys of D, this will return what? Tell me. Keys of D will return what? In general, keys D returns what?
The value,
List of
Value
keys.
of that key.
the list of keys.
List of keys. Okay, not just keys, list of keys of dictionary D. Okay, so I will get a list. Now, within that list, I have to use the for each block to traverse, right? Within a list, there is no other way to traverse. So if key is equal to k, for each key in keys of D, now I will check every key with this k that I'm trying to check for, whether it is present in the dictionary or not. So I have to check against every key. So if key is equal to k, that means found will be now assigned the value true, and we will exit the loop. Okay, exit loop statement does what? It will end the iterations for this for each block, right? I will just exit it midway because I have already found it. And if this k is not a key, that means this statement will never be true if it is not a key already. Correct? If k is not a key of dictionary D, will this statement be true ever?
No.
No, ma'am.
No. That means found will also never be true. So I will iterate through all the keys of dictionary D and this found will still remain false. So when I return found, its value will be returned as false. That's why when a key is not present in dictionary key, is key function returns false. But if it is present, then found is set to true and I exit the loop and return found, which is set to true now. So for every key that is present in dictionary D already found, this is key procedure returns true. So is key procedure, how it works, is it clear everyone?
Ma'am,
Yes, ma'am.
ma'am.
Yeah.
Please explain line number 3 for
This one? This line? Hello? Am I audible?
Yes, ma'am.
yes, ma'am.
This line you're asking for each key?
Yes, ma'am.
Okay, first tell me keys of D is returning what? List of keys of dictionary D, right? So in the previous runs dictionary, if I am taking that, then keys of D will return what? A list with all the keys. So Kohli, yeah, Kohli, Rohit, Sky, everything. Okay. Like this. These are what? These are the keys of D. Now, is key procedure is searching for this key K. Let's say K that I'm searching for right now is Dhoni. Okay. And Dhoni is not present in my list yet. Okay. So first found variable is set to false. Now this for each key in keys of D. This is iterating through which list? This list. So for each key in this list, that is for each entry in this list, I will check, I will compare with the key that I am searching for. So it will compare with Kohli, with Rohit, with Sky, but it will never find a match, right? Because Dhoni is not present in my dictionary T as of now. So found will remain false, because if only this was true, then only I will enter this if block and set found to true. But since it is not true, so it will iterate through all of the keys in dictionary D, but still found will remain false at the end of execution. So when I return found, it will return false. Now, if instead of Dhoni, I was searching for Sky, then for each key in keys of D, there will be a match between this and this, right? So when this key, the for each block reaches this key, that is this element in the list, then it will find a match and it will set found to true. Then I will exit the loop because I've already found a match. No need to do further iterations, and I will return found, which is true. Clear now?
Yes.
If found
Yes,
is
ma'am.
false, we won't exit the loop, right?
If found is false, as long as found remains false, we will not exit the loop. We will have to keep on iterating, because when is the exit loop statement given? When found is true. Once I set found to true, then you can exit. Okay.
All right, ma'am.
This is, I think, the same thing. Checking for a key. Okay. So that's pretty much, these are pretty much the main dictionary functions that you need to know. One is the keys function, one is the is key function. Keys is what? List of all the keys present, and is key is what? It is a function to check whether a key is present in dictionary D or not. Okay. So what did we learn so far? That dictionary stores a collection of key value pairs. Random access is possible using key, right? I can use any key and get the corresponding value. No need to do no need to traverse from the beginning to end, like in case of a list. A dictionary is a sequence like this: K1, V1, K2, V2. These are what? Key value pairs. Usually, create an empty dictionary and add key value pairs. So usually we create a dictionary first, then we add the key value pairs to it. Then how do you iterate through a dictionary? You first get the list of keys, and then for each key, you can iterate through the list, and you can do anything you want with the values. And for is key function, what do? It reports whether K is a key in D or not. So if is key DK, if this is true, if this part returns true, then we just update the value of K. Okay, we just update the value that is against key K in dictionary D. But if this returns false, that means K is not a part of dictionary D. So we create a new entry for that key and assign it a value. Okay. So far, anything that you didn't understand? Anything you want to repeat?
No, ma'am.
Okay.
No, ma'am.
Then we'll see some more complex pseudocodes. Okay. Now
I have a
this,
question here. Sorry.
yeah.
When you come for the dictionary, I mean, this key, when it's the dictionary is empty, what will be the case? Because the what will be the status? It's the boolean will be true or false. How it will act there?
If there are no keys in your dictionary, then there is nothing to compare with. So found will remain false. Right. In an
And so
empty
if
dictionary, this key will always give you false.
okay. And the other thing is like when we have the key with the same multiple values or multiple keys and variables, and we have created a dictionary. So is it possible that once we create a dictionary, can we drop some of the thing from the dictionary, or it's once it's created, it all be the same?
I didn't.
Can we drop the elements? Can we drop some of the keys from the created dictionary? Can we
Because you
delete?
want to delete.
Ah.
Yeah, you can delete keys from your dictionaries. Okay. That is fine. But the main thing to remember is that no key should be duplicate. Okay. Values can be duplicate, but keys will be unique. So you can drop elements if you want.
Okay. And if for the same key, I can have multiple variables of them, right? More than one variable.
No, the key value pair is unique. Okay. For key 1, if the value is V1, then this key 1, K1 is to V1. This pair is unique. You cannot have one more K1. But another key, K2, can also have the value V1. That's possible.
But K1 can have V1, V2, V3 like that, am I right?
Yeah,
Can
but
have
in the
multiple.
form of a list. In the form of a list that will be present.
Okay.
If a
Okay.
key is associated with more than one values, it will be in the form of a list. Okay.
Okay.
Now, see, in this PDF, whatever pseudocodes we are going to learn, it's a little tricky. Okay, so pay attention to this. See, the first example is customers buying food items. What is this doing? Find the customer who is buying the highest amount of food items. So in the shopping bills data set, this is from the shopping bills data set, right? So if you see a card, what does it look like? It has a customer name, it has a store name, and a sequence number, the items the person has purchased, category of items, uh, per unit price of each item, and total price, right? This is what is present in the shopping bills data set. You can go and look at it. So what do I want to find? I want to find the customer who has bought the highest amount of food items. That means the person whose list has the highest number of food items. So each item has a category associated with it. If some, I'm sorry, let's see, if one customer has bought carrots. So what is the category of this? Food and vegetable, there is one category, right? So it will fall under that. So I am trying to find the person who has bought the maximum number of items from this category, food category. So how will I do that? See. First, we will create a dictionary to store food purchases. Okay. Where customer names are the keys. That means customer names are what? Unique. Number of food items purchased are the values. So basically, I want to create a dictionary D, let's say, which will have customer name, say K1 is a customer name, and correspondingly, this V1 is what? Number of food items purchased by K1 customer. Clear? So like this, there will be the key value pairs for every customer, K2, V2, like this. Okay.
Excuse me.
Yeah.
The question is find the number of customer who buying the highest amount. The amount is the amount spent or the number of items?
No, it means number of items from food category.
It could have been clear, no? When the question comes, when probably we get, at least I probably will look at amount is normally the money, then the value. Then I will go into the value, the code will be wrong.
No, see, the code first of all will be given to you. Okay. There is no part of writing the code. It will be given to you and just ask questions from the code. But here, when we are saying highest amount of food items means highest number of food items. Okay. So food D is first an empty dictionary that I'm initializing. Now, while table 1 has more rows, this is from where? This is from the shopping bills data set, that table. Okay. So read the first row X, that is the first card. Now we have a variable called customer and a variable called items. So customer variables it has X dot customer name. That means customer variable will store the customer name from X card. Okay. Items is what? Items is actually, it's the name of a list. Okay, because one person has obviously bought more than one items. So X dot items will give me a list of items that I'm going to store in. A person can also buy a single item, that's also fine. But mainly in the dataset, you will see that a person has bought more than one items. So that all the items that he has bought, I will store them as a list in this items list. Now, for each row in items, now for every customer, I will iterate through this items list for the customer and check every item he has purchased. So for each row in items, if row dot category is food, okay, why is it saying row? Because in the shopping bills dataset, how is it listed? If this is item 1, then there is the category, then there is the price, then total amount, that is price per unit into number of units purchased, right? So these are one rows, one row for every item is given for each customer, right? So that's why it's written for each row in items. If row dot category is food, that means the item that the person has purchased in that row. If it is from food category, let's say it's the first row has item name carrot and the corresponding category is food. So row dot category equals to food. This will be true for carrot. True. Now, once this is true, I will enter the nested if. Nested if is doing what? It is checking whether that customer is already present in this food D dictionary or not. Okay. So we are using which function? IsKey function. IsKey will return true when customer name is already a key for food D dictionary. So if it is a key, then I will do what? Food D customer. I will increment the value that is associated with that customer name by 1. That means I have found one item from food category that this person has purchased. So of course I have to increment the associated value by 1. Okay. Otherwise, if say the dictionary is empty, initially the dictionary would be empty. Okay, food D is initialized as empty dictionary. So the first card, when I look into the first card, let's say for some customer XYZ. So when I come to this if block, okay, row dot category is equal to food. So if the first row is say an item from food category, then it is fine. I will go to this nested block. Now, initially, if this is the first thing, if this is the first entry I'm checking, what will IsKey return, true or false?
False.
False.
Because dictionary is what? Empty. So it will return false. So if it returns false, I will enter here or here.
The
In
else
else
block.
part.
Else block.
Else block, right? So else block is doing what? It is creating it as a key. So in food D dictionary, now I will create the a key for this customer XYZ and assign it the value 1. Why 1? Because I have found one item at least, which is from food category. Okay. Now, let's say the first card X that I picked. This person has bought 5 items from the food category, 5 different items. Okay. So the first item I found and I created the key for the customer and I gave it 1. Now I go to the second row. See, in this loop. So for each row, now I will go to the second row. Even in second row, I see that the item category is food. Let's say he has bought eggs. Okay. Then again, the item category is food. IsKey. Now you check here. Is customer a key of food D? What will this return now?
True.
True.
True, because I have created it in the previous step. So now I will do what? I will just increment the value associated. Because what do I want my key value pair to represent? Customer name is to number of items, food items purchased. Right. So food customer, food D customer, that is for that customer, I will increment the value by 1. So at the end of this for loop for the first customer, if that person has purchased 5 items from food category, 5 distinct items, then at the end of the iteration of this for each block, what will be the key value pair? XYZ is to 5. Is this clear? How I'm getting 5?
Yes, ma'am.
Because it will keep on incrementing here every time we encounter an item that is of food type for this specific customer. Okay. So like this, if I do it for all customers, then my dictionary food D will look like what? K1 is to V1, K2 is to V2. These are what pairs here? Customer name. This is what? Number of items purchased from food category. So now I have this dictionary. Now I can easily look which value is the highest, right? So that's what I'm trying to find, customer who is buying the highest amount of food items. So I can look at the dictionary and see which value is highest. If more than one people have purchased the highest number of food items, that also is possible because values can be duplicate, right? Is this code clear to everyone?
So,
Yes, ma'am.
Yes,
in
ma'am.
order to like find the customer who buys the highest amount of food items, we have to go through the data of the dictionary.
Yes, after you have created the dictionary, then you can look through it to find. Okay.
Achha, ma'am. Okay, ma'am. Also, if you wanted to, rather than just add 1 to it, if you wanted to create a list of the customers, like each customer along with the food items that they are purchasing.
That
So for
also you
that,
can
you
do.
have to append in that, right? Food.
Yes, that you have. Then you have to create what for each food customer. Okay. Then each entry for the customer, that is the value part of that, will be a list instead of a value like 1, 2, 3. Okay, it will be a list. So in that list, you keep on appending the names of the items. That also you can do. We'll take an example like that also.
Okay, ma'am. Okay. Thank you.
So is anyone familiar with what is the birthday paradox problem? I think I told you about this once. Anyone remembers?
Yes, ma'am.
Yes, ma'am.
When more than one student have the same birthday,
So they have the same month and the same date, right?
date of the birthday.
Yes. So the birthday paradox problem, now we will see how we can find those duplicate birthdays and everything. That is, which people have the same birthdays, how we can solve this using the concept of dictionaries. Okay. Mainly, the birthday paradox problem itself says what? That no matter how small our data set is, that is, even if we have 5 students in our data set, then also there is a high chance that 2 of them might be having the same birthday. Okay. So find a birthday shared by more than one student. So for now, this is the goal. No, see, birthday paradox. Now this code that you see, we will keep adding to this code. Okay. So just keep in mind what each dictionary is representing here. So first I have this dictionary, birthdays. This dictionary will have what? Every unique birth date. Okay. Every date on which a student has birthday. It will contain that. Duplicates dictionary will contain what? Only those birth dates where more than one people are born. Okay. Now see, initially both dictionaries are empty. Now, while table 1 has more rows. Okay, this is what data set?
Course data set.
Scores data set. Good. So while table 1 has more rows, I pick the first card, X, in table 1. Now I have a variable called DOB. Okay. DOB stores what? The date of birth of that student whose card I have picked. So DOB equals to X dot DOB. Now, if is key birthdays DOB, initially birthdays is empty, duplicates is empty. So for the first student that I have picked, this will return what?
False.
True or false? False.
False.
Because there is no entry. So I will create an entry. So now birthdays DOB is true. Let's say the first person whose card I picked has birthday on 5th Feb. Okay. So now after I have created the entry, now my birthdays dictionary, it looks like this. 5th Feb is to true. Clear? Only one entry is there right now. So now if I pick the second card, let's say that person is say born on 3rd of March. Okay. So I'm going to first again assign this 3rd March to what? DOB. Then if is key birthdays DOB, this will return what? True or false? False. Because no keys are present that match 3rd March. So I will again create a key. So at this point, now birthdays looks like this. 5th Feb is true, as well as I have an entry for 3rd March, which is also true. Now, let's say I pick the 3rd card. 3rd card is again a person who has birthday on 5th Feb. Okay. So now if I assign this 5th Feb to DOB and then come to this if block, what will this is key give me?
True.
True.
True. Because 5th Feb is already a key in the dictionary. So I will just do this. Now I will go to duplicates dictionary and create an entry for that date of birth. Why? Because whenever this part returns true, I know that I have reached a duplicate date of birth. Correct? Because this will only return true when already that date of birth is present in my birthdays dictionary. So when will it be present? When already some person has birthday on that date. After that, if I pick a card where another person has birthday on the same date, then only this will return true. Otherwise, it will always be false and I have to create a new entry. So this returns true means more than one people have birthday on that same DOB. So in the duplicates dictionary, once this is true, I will go to the duplicates dictionary and create an entry for that date of birth. So right now, duplicates contains what? 5th Feb. And what is the corresponding value? True. Okay. So every time you pick a card which has a unique date of birth that is not a part of birthdays dictionary yet, that is not a key of birthdays dictionary, you have to create a key, right? You have to create an entry for that DOB and this true false pair in the birthdays dictionary. But if this returns true, then you will add that to the duplicates dictionary. Okay. So now tell me, if the fourth card I pick is also a person with the same birthday 5th Feb, what will I do? Will I create one more entry
No.
in duplicates?
No.
No. Why? Because a dictionary cannot have duplicate keys, right? All keys have to be unique.
Is it necessary for a dictionary to be in a order?
Sorry, you're not audible. Come again.
Is it necessary for a dictionary to be in the order?
Necessary for a dictionary to be?
In the order.
In ordered form.
No, it can be anything. Okay. So you are randomly picking the cards, na? So it can be anything. See. Now, if the fourth card is also from someone who has birthday on 5th Feb, then if is key birthdays DOB, this will return true again. So if you go here and try to create this key, this is already present, so no new key will be created. Okay. Only this 5th Feb true will remain there. Because keys cannot be duplicate. Now, in this problem only, I am going to add some new things. See, right now, till now, what we have done, find a birthday shared by more than one student, create a dictionary with date of birth as keys, record duplicates in a separate dictionary. If we want to record the now, we want to record the names of those who share the same birthday. And I want to store a list of student IDs against each date of birth. So now I want the names of the student. So where will I get the names from? For that, I need the sequence number of the card, right? So what am I doing now? See, same code, birthdays, duplicates are initially empty dictionaries. Then I'm reading the card, and in DOB, I'm storing the date of birth of that card. Now I have added a new variable called sequence number. What is sequence number storing? The sequence number of the card X. Okay, this line is new from the previous code. Okay, so if is key birthdays comma DOB, same thing. I'm checking whether this date of birth is already a key in birthdays dictionary or not. So if it is false, then you will go to the else part. So initially, the first card we picked, I told you that it had birthday 5th Feb. Okay. Let's say the sequence number associated to this card was 001. So for initially, the birthdays dictionary is empty. So this will return false. So I will go to the else part. And I will create a key for this date of birth, 5th Feb. So birthdays, 5th Feb. What is the value? Value is a list containing 001. Okay. So what does birthdays dictionary look like now? It is 5th Feb. But against it, instead of true or false, we have 001 in a list. Okay. So now the second card I picked in the last example had birthday what? 3rd March. Okay. And say the sequence number is 002. So for this will return false, right? So I will again come to the else part and add this to my dictionary. So now there is one entry for 3rd March and corresponding sequence number is 002. Now, the third card I picked, that is again someone who has birthday on 5th Feb, and say the sequence number is 003. So what will happen? Is key will return what? True or false?
True.
True.
Now, true means what? It is a duplicate date of birth. It will only be true when it is already present in birthdays. That means more than one people have this same birthday. So I will create an entry in duplicates dictionary, right? And against it, I will put true value. So duplicate still looks the same like the last code only. But now there is one more line here, which is new. In birthdays DOB, I am going to add this sequence number to the list. So after I add it, it will look like. So it had 001. Now I have also added the sequence number 003. Okay. So is this clear? This code is clear for everyone?
Yes, ma'am.
These two, this one and this one. Any confusion till now? Tell me.
No, ma'am.
Okay. Now see, I'm going to make this a little bit more complicated. So what happens now? Find a birthday shared by, okay, all of these things are same. Now here, we can also store the students associated with each date of birth as a dictionary. Okay. So till now, I had two dictionaries, birthdays and duplicates. Birthdays was what? It was storing each unique date of birth. Okay. And against it, the sequence numbers that are associated with that date of birth. That means the sequence number of cards of those people who are born on that date. And duplicates dictionary was carrying what? The unique dates for those birthdays where more than one people are born. Okay. And the key value pair looks like date is to true or false. Anything it can be. Okay. Now, till this, everything is same. Again, sequence number, actually all of this part is same. Okay. Till here. So first entry, we know 5th Feb. For that, I will have an entry in birthdays. Again, I will have 2nd March entry in birthdays. Again, when I get one more 5th Feb entry, then I will have an entry in duplicates. I will add 5th Feb to duplicates and assign it the value true. Okay. Now see, simultaneously, what is this line doing? So this is what you called a dictionary within a dictionary. You can think of it like that. Okay. So for every birthday itself, now I have a dictionary associated with every sequence number. So here you can think of this part, birthdays DOB, as the dictionary name. And this sequence number is what? The key. Okay. So this is a separate dictionary from the actual birthdays dictionary. So what are we trying to do? Store the students associated with each date of birth. So birthdays DOB, let's say there is one birthdays 5th Feb. This will store what? For every sequence number that is associated with this, I will assign it true. If they are born in 5th Feb, okay. So birthday 5th Feb is now what? A separate dictionary with what are the key value pairs? What will be the key value pairs of this dictionary? 001.
Sequence number.
True. Okay. Again, for the third person, and the birthday was 5th Feb, so 003 will also have true. So these will be the key value pairs of this birthday 5th Feb dictionary. Okay, this whole thing is a dictionary. 5th Feb is not a key. What are the keys? The sequence numbers are the keys of this dictionary. Clear?
This
See.
will
Not
include all the
understanding
duplicates as
duplicate.
well as all the birthdays in that case.
Sorry, everyone was speaking at once. Just say again.
It means you mean to say this will include all the data set like duplicates as well as all entries, dictionary.
See, this birthdays DOB. How many number of such dictionaries will be present? As many unique date of births as there are.
So means it will have all the values, no? That's what all the
Yes.
student values, right?
Yes. All the sequence number associated with each birthday. So those will be the keys. Okay. So for 5th Feb, what are the sequence number associated? 001, 003. So these are the keys for birthday 5th Feb dictionary. Again, I can create one more dictionary, birthdays 3rd March. For that, 002 is the key. Okay.
This new structure does not capture any additional information than the earlier one that we just now saw.
No. It will make sense. Okay, let me finish.
Okay, now you're building something. Okay.
Yeah.
This is dictionary under dictionary. Nested dictionary, you can say.
Yeah, you can think of it like a nested dictionary. Because the original
instead of true, can we store any other value?
Instead of?
True. Like if you want to know how many repetitions happened, so we could iterate it like some I value and then
If
I
you
plus
want to
1, I plus 2.
if you want to find how many how many people are born on each birthday, yeah, then you can go to the duplicates dictionary. Right, there the key value pair is already giving you that, because what are the values in that dictionary? See, here also, okay, I understand what you want to do. Yeah, we can get the number of people who are born on the same date also. We can create a list of sequence numbers, right? Against each birthday. That is also possible. But here what is happening? First, let me clear all this and take an example so we understand why we are doing this. Okay. Let me take a small data set. Okay. First card is 5th Feb. Sequence is 001. Second card is 3rd March. Sequence is 002. Third card is, let's say, 2nd April. Sequence is 003. Fourth card is again 5th Feb. And sequence is 004. Let's say this is our data set for now. Okay. So now check what is happening. Look,
Ma'am, actually,
first birthdays.
she's saying that can we escape this line, ma'am? Actually, we can do it in a one line. So why it is you have to add
Yeah,
another line?
I will tell you why I'm doing this. Okay, just let me run the code once, then I'll tell you. Okay. See, first we have two dictionaries which are empty, birthdays and duplicates. Now, what is our goal? See, first of all, we wanted to find a birthday shared by more than one student. This was the goal. This is the actual birthday paradox problem. So what am I doing? First, creating a dictionary with date of births as keys. What is this? This is the birthdays dictionary, which will have all the unique date of births that are present in the dataset. Okay, these are the keys. Record duplicates in a separate dictionary. Duplicates dictionary has only those date of births on which more than one people are born. Those date of births are the keys in duplicates dictionary. Now, if we want to record,
the values are true, right? The values for
yeah,
this.
the values are true. For duplicates, values are true. Initially, for birthdays also it is true. Okay. See, if we want to record the names of those who share the birthday, store a list of student IDs against each date of birth. So now, for every date of birth in the birthdays dictionary, I am going to be storing a list. Okay, a list of sequence numbers. So the corresponding value to a key, it will be a list, like we did here, right? See, duplicates DOB is true, and then if it is a duplicate, then I am adding the sequence number. Okay. So initially, whenever I'm creating a key value pair in birthdays, it is like this. K1 is to V1, and V1 is a list of sequence numbers, not a single value. And every time we find another sequence number which has the same birthday, I just add it to the list. Okay. So here what's happening? Now it is saying can also store the students associated with each date of birth as a dictionary. So now I want to create a separate dictionary for every unique date of birth. That's why I'm doing this. Every unique date of birth should be a separate dictionary itself. And what will be the key value pair there? There I will have keys as the student sequence numbers.
Yes, ma'am.
Okay. And corresponding value will be true. If it is present, then true. Otherwise, not. See. While table 1 has more rows, read the first row. So this is the first row, 5th Feb. So DOB is at this point what? 5th Feb. Sequence number is what? 001. Okay. So if is key is, I'm checking, is this DOB present in birthdays? Initially empty, so false. So I will go to the else block and create this dictionary. See, it is creating this empty dictionary. Birthdays, what will be here? This dictionary is for 5th Feb birthdays. So birthdays, 5th Feb. This whole thing is a dictionary. Okay. It's not a key, it's a dictionary name along with the date. Birthdays, 5th Feb. This is the dictionary and it is empty initially. I just created it. Now, birthdays DOB. Sequence number is the key. What is the sequence number? 001. So 001 is to true. Okay. So at this point, tell me, let's just write all the dictionaries that we are using. So birthdays is one dictionary. Okay. What is this dictionary storing? Every unique date of birth and corresponding true, right? So right now it looks like this. Then duplicates is currently empty because I have only seen one row. It is currently empty. And I have formed a new dictionary called birthdays 5th Feb. This dictionary has the key value pair currently 001 is to true. Does everyone agree with this
I
till
don't.
now?
I don't.
Yes.
The last three
Okay.
lines which you wrote in that 3 line, the first line should be birthday, curly bracket, 5th February. In the value, it is not true. It should be the another dictionary. Open
No, I am talking about the birthdays dictionary.
Yeah, I'm talking about the birthday dictionary is key is 5th February. The value is not true. The value is another dictionary. A curly bracket
Wait, one second.
001.
One second. Here.
No, I'm not talking about this page. This page, the one which you are
See,
right now.
in this page,
Yeah.
is it right now? Is it given that I am using sequence numbers?
What I'm just going through the code. The first, if you look at the first, just after the else, and it is creating, the birthdays will be looking empty.
Look, this is not birthdays dictionary. This is a new dictionary I am creating for birthdays 5th Feb. This is the birthdays dictionary, okay? Where I'm checking the is key. This is the birthdays dictionary.
The value put that as a curly bracket, so it should appear as a curly bracket, not as a tree. True. What I'm saying is
No. This is not value. This is not value. This is an initialization of a new dictionary.
Fine.
This is not the birthdays dictionary. This is birthdays BOB dictionary.
Okay.
Okay. This birthdays dictionary that I've written is the first birthdays dictionary that we've learned here. Okay. So here each entry looks like what? 5th Feb is to true. Okay. This is the one I'm talking about right now. And the birthdays
we don't have
DOB
the statement
dictionary.
here. No, we don't have the statement here.
See, it is
It
the
has to
same
be-
code where I'm adding more and more lines as I want to do something extra. Okay. But the dictionaries initially, whatever I what can I say? Whatever I told them that they're representing this, that representation remains same.
Okay.
Okay. So
It is
first
a
birthdays.
continuation of the previous
Yeah, it
things
is the
that we have
continuation
done.
of the previous one only. Yeah. See. So birthdays dictionary has this key value pair. Duplicates initially right now it is empty because I have only seen one row. And birthdays 5th Feb. This is a separate dictionary. Now I am going to create separate dictionaries for every birthday. Why? Because I want to store the students associated with each date of birth as a dictionary. This is the goal right now. So I have to create a separate dictionary for every unique birthday. Okay. So can anyone tell me how many such dictionaries will be present?
Depends
As
upon
many
the
number
number
of unique birthdays.
Dates, ma'am. Date of birth,
The
ma'am.
number of keys of this birthdays dictionary, that many.
Yes.
Correct?
Yes,
Because
ma'am.
those are the unique date of births. Okay.
Ma'am, I wanted to ask something. In previous Pseudo code, previous one, we were able to find the students, right? The sequence number. Yeah. So why to complicate the things? Here also we can find out that on 5th February 001 or 6 3
No,
whatever.
actually, what they want to do in these birthdays, yes, you are right. Earlier, what we are doing for every birthday, we are storing a sequence number as a list. Like all the sequence numbers come in this list for this birthday. Sure, this is fine. But now I want what? I don't want to do a dictionary within a. I don't want to find a list like this. Okay. For every birthday, I want a separate dictionary. It is just the requirement of the code. Okay. If they are just asking us to do. No,
See,
it is
actually,
not.
the thing is that
Like,
madam, what
are we
madam wants to do that?
making dictionary or keys for separate last key? There will be separate keys for every.
Yes, list of. Yes,
I just
list of
want
the
to
keys.
create. I just want to create separate dictionaries for every unique birthday, and the keys should be representing what? The keys should be representing the sequence numbers. Now, so if I want to check for any
one
birthday.
sequence number, you mean to say that one sequence number will be a dictionary for every?
No, see, you're confusing things. Okay, let me clear it up firstly.
For
every.
Can I clarify?
Just let me complete first. Okay.
Please.
Birthdays dictionary has unique date of births on which people are born And for every unique date of birth, there is an entry in birthdays dictionary. Duplicates has only those date of births on which more than one people have been born. For those dates only there are entries. Now, for every unique dates of birth in birthdays dictionary, I want to create a separate dictionary. Okay. So if there are 10 unique dates of birth in my birthdays dictionary, I will have 10 separate dictionaries, each of which will be representing a separate date of birth. And within each of these dictionaries, these 10 dictionaries, what will be the key value pair? The sequence numbers of those students who are born in those dates of birth. Okay. So on 5th Feb, currently I have just seen one row. So on 5th Feb.
So basically, ma'am, the result will be same like of the previous pseudocode and this one. Yeah, our requirement is fulfilled in the previous one also.
No. See, what was the requirement in previous one? We just wanted to store a list of student IDs against each date of birth. Okay, that's why I took the list. But right now the requirement is what? I want to store the students associated with each date of birth as a dictionary. So each date of birth should be a separate dictionary in itself.
Can I at least say something?
Yes, sir.
Okay, I think the concept of a dictionary is a little unclear to some of the students. I'm not saying all. Dictionary is just a pair of key and a value.
It is a key value pair.
Value can be of any type. It can be a true or false Boolean, or it can be a numerical, or it could be a list, or it could be another dictionary itself. In the earlier example, or I would say one before that, what we were storing in the dictionary of a birthday was the date of birth as the key and true or false as a Boolean.
As the value.
Second time, instead of the Boolean variable, we changed it to a list variable.
Yeah.
It's included all the students' sequence number whose birthday is the same. Now, the third attempt, instead of keeping it as a list, we are only playing around with the type of the value.
Exactly. So instead of keeping it as a list,
dictionary, in future, if any other information can be stored, it can be inserted. That is the reason.
Right. So instead of just keeping the sequence number as lists, I mean, instead of each key value pair being a key is to a list pair, instead of that, we are making separate dictionaries.
Key will remain key. Yeah.
So instead of the value part being a list, instead of the value being a list, I am making separate dictionaries instead of that.
That's what you're doing.
So this is easier to access. In a list, you have to traverse, right? If you want to find, then you have to traverse. But in a dictionary, if I create separate dictionaries,
you got to tell them. In a list, if you want to identify a sequence number, you got to iterate through all the sequence keys. Whereas
but in dictionary, I can randomly access. Yes. Using the key value pairs, I can randomly access.
That is the purpose.
So now let's do the next iteration of this. Okay. So next row is what? 3rd March. Okay. So read the next row, 3rd March. Now DOB is at this point. I'm going to change all of this again. So now DOB is what? 3rd March. Okay. And sequence number is what? 002. Is 3rd March a key in the birthdays dictionary? No. So I will create a separate dictionary for 3rd March now. Okay. So that will look like what? Birthdays, 3rd March. This is the dictionary name. Okay. It is initially empty. Okay. Created it. Then I added the key value pair. So it now looks like sequence number is what? 002 is to true. So for every unique birthday, you see there is a separate dictionary itself. Okay. Now go to the third entry, 2nd April. That is also a new one. So for 2nd April also, I will have a dictionary like this. Birthday, 2nd April, what will be the key value pair? 003 is to true. Now, 4th row when I come, I have 5th Feb. So DOB is 5th Feb. Sequence number is what? 004. Is it a key of birthdays? Yes. So I will enter this if block. And whenever this is true, that means I know it is a duplicate date of birth. So duplicates DOB needs to be updated. This duplicates dictionary needs to be updated. So now duplicates dictionary will have the key value pair 5th Feb true. Okay. Next, here. Since this is already a key, that means it already has a separate dictionary of its own. This one, birthdays 5th Feb, already present. So I will just update it. That means I will add a new key value pair to the already formed dictionary birthdays 5th Feb. So right now this dictionary will be updated to what? 001 true was the only element. Now it will be 004 true. Clear? Everyone now? Any confusion now?
Yeah,
So if this birthdays dictionary has 10 unique birth dates, then how many this type of dictionaries will I have? 10. Birthdays DOB. 10 different dictionaries will be there. So as many unique birth dates, that many unique dictionaries. Okay. So birthdays paradox problem will be ending here. No more codes are there for this. Any confusion from any of these three codes?
I have small clarification here. When we have a birthday data DOB and the sequence number, that means the sequence number is unique by itself. So again, do we have to confirm with the true there?
Which line can you tell me, please?
The
sequence numbers are
This
unique.
one?
Yeah, this one.
This one you are asking?
Yes.
This is
Sequence
not
numbers are
checking.
unique.
Okay. This is not checking. This is creating a key value pair.
Yeah.
Okay. Sequence number are always going to be unique. So every key is unique in this birthdays DOB dictionary. So for birthdays 5th Feb, firstly only this key value pair was present. Now one more sequence number 004 has the same birthday. So in this birthdays 5th Feb dictionary, now I have one more key value pair, that is 004 is to true. That is what is assigned here.
So instead of true, we can set it as any constant value.
No. See, for every date of birth, you have to check all the key value pairs. That is the sequence numbers that are associated with that birthday. You have to make an entry for every sequence number.
Sequence number is unique and it is not.
It itself
Yes,
is a key,
sequence
no,
number
now.
is always unique, right? You have checked the
that I
data
understand.
sets.
But instead of equal to true, we can have any other value as well.
You can.
Yeah,
You
value can choose anything
value
that
can
is
be
You could put the
anything.
name of the student.
Yes, anything
Or
you can
keep the
have as
name
a
of the
value.
student.
X
Value.
dot
Name.
X dot name. You can store that in some separate variable here. In some name variable, you can store x dot name and then assign it here.
That's so
That
easy.
will also work. In this example, we are assigning it the value true. Okay.
Okay, thank you.
Okay. So if nothing more, then I'll go to the next problem. See, now we are going to solve this problem called resolving pronouns. Okay. So this problem is from your paragraph dataset. Okay. So what have we seen in that dataset? Each card has what? A word written on it, right? A word is there in and the part of speech of that word, what is the letter count, all of these things are there. So in paragraph datasets, whenever we have come across questions, a paragraph might be given to you, and based on that, I can ask questions like find the number of words where the word is starting with a particular letter. This type of questions are there. So in this resolving pronouns problem, what happens? We know that the paragraph can have pronouns like he or she present in it, right? So there are a number of sentences in the paragraph dataset. There can be a number of pronouns present in each sentence. So the question is that whenever we encounter a pronoun, he or she, how do I know that which noun is it associated to? So usually the way of thinking is that the pronoun that we have currently, if I have this he pronoun in a sentence, then the last preceding noun, proper noun that is there, this pronoun is associated to that noun. For example, if I have a sentence called Rahul is a boy. Okay. And next sentence is in paragraph dataset is, let's say he is 10 years old.
He is related to Rahul.
So this he, what is the preceding last proper noun? Rahul.
Rahul, ma'am.
So this pronoun is related to Rahul. But see, this is not a foolproof solution. Why? Because there can be a sentence like, say, Rahul is a boy. Let's say, Mr. Singh is his teacher. Okay. Okay. Now, after this, you have he is 10 years old. Now, this he, what is the last preceding proper noun?
Mr. Singh.
This.
Mr. Singh.
But this is
But
wrong.
it refers to
This he
Rahul.
is actually referring to Rahul. But according to our algorithm, it will go back to Mr. Singh. Right. So this is wrong. So it's not completely foolproof yet. We are going to follow this only because we are currently not able to find a better solution to this problem. Okay, if you go through the videos, the professors have explained it much better why we are following this algorithm. So just go through that lecture once. But currently, we are only going to look at this algorithm like whenever a pronoun, we come across a pronoun, the last preceding proper noun or the nearest preceding noun is the matching, is the noun that is associated with this pronoun. Okay. So now I'm going to write the pseudocode for this. So first I have to create a dictionary with part of speech as keys because noun, pronoun, these are what? Parts of speech, right? So these dictionary, it will have part of speech as its keys, and each of these keys will have a sorted list of card numbers as values. Sorted list, okay. Not in any order, it has to be in sorted order. Now let's see how this works. First we have an empty dictionary called parts of speech. Okay, it is empty. This dictionary will only have two keys. One is for noun, one is for pronoun, because that's all we are interested in. So part of speech noun will have, again, a list of its own. That means for this key noun, the value will be the value, there are more than one values associated to this key. And those values I will store in a list. Similarly, for pronoun, there are more than one values associated with pronoun. And those values I will store in a list. So what are these values that I'm storing in the list? It is the sequence number of the cards. Okay. See, while table 1 has more rows, read the first row X in table 1. Now, if part of speech is noun, so in each row, that means each card has what? A single word on it. Correct. If you have seen the words or paragraph data set, each card has a single word on it. And the part of speech of that word is also given. So every time you pick a card, you will first check, is the part of speech of that card noun? If it is a noun type of word, then you will come here. So part of speech noun, that means for this noun key, you are going to append the serial number of that card to this list. Okay, so part of speech noun, append X dot serial number. So if you pick a card that is of noun part of speech, then you are going to add the serial number of that card to the list of values against noun. Okay. Similarly, if you pick a card whose part of speech is pronoun, then you are going to add the serial number of that card to the list of values of pronoun key. So there are only two keys in part of speech dictionary, noun and pronoun. Now let's say let's say in this part of speech dictionary, I am mainly going to have two entries, right? One for noun. Now the entry for noun, this is what? A list. This list contains what? Sequence number of all the cards that I have picked that are of noun part of speech. So let's say the part of speech of these are, the serial numbers are 2, 5, 8, 10. I'm just randomly taking. And then again, pronoun is also one more key of this part of speech dictionary. And it also is associated with a list of serial numbers of those cards which have words which belong to the pronoun part of speech. Let's say these are what? Anything you can take. 9, 15, 21, 37. Okay. So if I tell you that, okay, first answer me, what is 2? What can I tell about this 2? 2 is the serial number of a card which contains a word whose
Noun.
part of speech is noun.
Yes.
What is 9? It is the serial number of a card which contains a word whose part of speech is pronoun. Now tell me, are there going to be any intersection between these two lists?
No.
No.
Because no word will be both noun and pronoun, right? So no intersection.
Yes, ma'am.
Now look at the code. Okay. So up to this, it is just creating these lists. It is just finishing the creation of this part of speech dictionary. Now here is the actual code where we will resolve the pronoun problem. So I have now one more dictionary called matchd. It is an empty dictionary initially. So for each p in part of speech pronoun, what does this mean? For each p in part of speech pronoun, that means I will iterate through this list, correct? So for every pronoun, I'm calling the pronouns as p. When I'm going to compare them, I'm going to call each pronoun as p. Okay. So for each p in part of speech pronoun, I have a matched variable, okay, which is assigned the value -1. Why -1? Because the serial number of cards start from 0. Okay, so I cannot assign it 0. So I'm going to assign -1. Now, within this, there is a nested for each block. So for every pronoun, I have to check with every single noun present in the list of nouns. Okay. So let's say this 2, this 9 is the first pronoun I have picked. Okay. So for each p, this p is currently 9. Okay. So matched is -1. Now come to the inner for each. For each n in part of speech noun, what is the first n? 2. Correct? Now enter this for each block. What is it comparing? If n is less than p. Okay. If n is less than p. So how is the serial number coming? That means n is less than p means n comes before p. Okay.
Yes, ma'am.
So currently my p is 9, n is 2. So 2 is less than 9. Is that true? Yes. So
Yeah.
enter the for each block and matched will be assigned the value n. What is n? 2. So matched is right now 2. Okay. Now check with the next noun.
Ma'am,
Our p is,
ma'am, this isn't it the card number, ma'am? 2 and 9.
these are basically, yes, this is the card number, but
So 2
look.
will be coming first, right, ma'am? So how come 2
No.
is smaller than?
Okay. Yes. Let me tell you. See, card numbers are what? It is, I am thinking of it like, if I pick the pronoun with card number 9, okay? For that pronoun, I have to check with every noun in the noun part of the list. So what are the card numbers for that? 2, 5, 8, 10. So what is my theory? That for pronoun 9, what is the last preceding noun that it is pointing to, right? So the last preceding noun should have card number less than 9, right? If we go in sequence order, if I have that sentence.
Then it's a position of card.
They have written card numbers, but you have to think of it as position only. See, Rahul is a boy. He is 10 years old. This was my sentence. Okay. So here, if I go position wise, so this is noun, right? Boy is what? It is also a noun. But in this case, I'm going to just take Rahul because I'm taking proper nouns. Okay. This is the pronoun. Okay. So whatever this pronoun has the card number, let's say this card number is 3. I'm just saying. Then the previous or preceding noun should have a lesser card number since it is in sorted order. See, it is always in sorted order. I already wrote that. Yes, sorted list of card numbers as values. So these lists, like one list corresponding to noun, one list corresponding to pronoun, these lists are itself sorted. Okay. So all the card numbers that are present in each list, they are sorted in ascending order. So if my first pronoun I picked is having card number 9, that means the noun that it is pointing to, it should be having card number less than 9 because it is a predecessor to that, right? It comes before this pronoun appears. So if I go sequentially, if I give, say, every card as card number 1, 2, 3, 4, 5, 6, 7, 8. Now I am checking for this pronoun 5. So whatever this pronoun is associated with, whatever proper noun this pronoun is associated with, it should have card number less than 5. Yes or no?
Yes, yes.
Because it will not
Yes.
come after the pronoun, right? It will come before the pronoun.
Mm.
So the card number should be less than the pronoun's card number. That is what they're checking here. So if the pronoun that I picked, the card number is 9 in my example, since I took these two lists, the first pronoun is at card number 9. So for this card number 9, I have to check this entire list of nouns until the condition is violated. So for the first pair, 2 and 9, is 2 less than 9? Yes. So matched is right now 2. This matched variable is 2. Okay. What is the next entry? 5. So check. Is 5 less than 9? Yes. So matched will now be what? 5. Again, take the next noun, 8. Is 8 less than 9? Yes. Again, matched is updated to 8. And what is the next one? 10. So is 10 less than 9? No. So I will come to else part and exit loop. That means I have found the proper position of the preceding noun. What is the position? 8. So the noun at position 8 is the noun that this pronoun is pointing to. See, this 9th position. Before this, only 8th position is present. Nothing else is present. Everything in this list of nouns after 8 is greater than 9. That means 8 is the pronoun that is preceding. 8 is the noun that is preceding pronoun 9. Okay, so once I violate this condition, that is this 10 less than 9, this is violating the condition, so I will exit the loop, and in the match D dictionary for the pronoun P, I will assign the value of stored in the match variable. So what is the match D dictionary looking like right now? Match D will have key value pairs 9 is to what is matched? 8. So 9th pronoun with 8th noun, that is card number 9 having the pronoun is matching with card number 8 which has the noun. Now similarly, let's check for one more. Next pronoun I pick is 15. Okay. Pronoun is 15. So P is 15 currently. For 15, again, matched is what? Every time you pick a new pronoun, matched has to be set to -1. That is, it has to be reset. And for every pronoun, I will go through each noun in the list as long as the condition is violated here, the if condition. So for 15, let's check. First noun is 2. Okay. So 2 less than 15? Yes. So matched becomes what? 2. Then I'll have 5. 5 less than 15? So match becomes 5. Every time this is true, keep updating the matched variable. That is, assign it the value of n. Okay. Next, 8. That is less than 15. So this becomes 8. And what is the last noun? 10. 10 is also less than 15. So ultimately, at the end of execution, matched will have 10. And what will be the next key value pair in match D dictionary? Tell me.
15.
15 is to 10.
10, ma'am.
10.
That is the last noun that is preceding 15. Okay. Similarly, for all of these pronouns, you can find out. Okay, so this is the way that we are resolving the pronouns problem. Now, tell me, is anyone having any issue in this code? Do you want me to explain this part again? Anyone?
Understood, ma'am.
Everyone understood, right?
Yes, ma'am.
Remember, this
Yes,
part
ma'am.
of speech dictionary only has two keys, noun and pronoun. And for each of these keys, I have a list of card numbers or sequence numbers. Okay. And in ascending order, they are both sorted in ascending order of serial number. Okay. So this is mainly the theory, all the codes that you have to see. One more thing that I want you to check out is this thing. One second.
I have a doubt here because in the real data, common data that the word said, there is a series of noun that is actually coming occurring there.
in the actual data set.
The actual data list. So
Yeah.
how
Okay.
it will
No,
function there?
that's what I said. Now that this thing is not foolproof. Okay, it's not always going to give you the correct result. This is just one way that we are using to we are just using this way to find that the last predecessor noun is the noun that the pronoun is associated with, but it is not completely 100% accurate. It might not give you the right result if you work this code on your data set. Okay, it's just one of the ways. So just check out the lectures for week 7 once. The professors have very well defined why this way is not foolproof. Okay. Now there are 2 lectures, I think lectures 4 and 5 maybe, where it is talking about the relationship between customers, right?
Yeah.
So those 2 lectures, it is best if you watch the lectures themselves, because from that part you won't be getting that much question. Okay, it is just for I mean, you can think of it as just theoretical knowledge. It is just like distance between 2 customers. These things are there.
Right.
That means the total number of items that they have brought. So those 2 lectures, you just watch the lecture. If you have any issue in the activity problems, you can ask me. But it is not that much important for actual problem solving in practice or graded from this week. Okay, those questions will come from what we covered right now, the dictionaries. Okay, so let's
but I think
practice
there are questions from distance and the thing in some of the activities.
yeah, there are questions, but those are very basic theoretical questions which you can answer if you watch the lectures only. Okay, so I am just going to solve some actual difficult problems from the practice assignment, so you can complete it, because on Wednesday you have the last date, right?
And I feel like this time the lecture, actually the questions that have been asked is actually prior to the lecture, because like if you take 7.2, actually I see that kind of a topic is coming after the
Yeah,
activity I studied.
some of them I know, some 1 or 2 questions are there which you have to read the next lectures to answer that properly. So that's why before you do any of the activities, complete all the lectures first. Okay.
Okay.
Then go attempt the
Because
activities.
I was going in the same sequential order that they have given.
Yes, yes. So for some weeks there are these things that you have to know the advanced lectures to do the basic activities. So should I start with the practice assignment? Has anyone attempted practice?
Yes, ma'am.
Touched upon that.
So,
Yes, ma'am.
so tell me which questions are you having problems in? I'll take those first.
Means all of the questions are complex.
Yes.
Ma'am,
Okay,
in
so
question
let's
3.
Just briefly explain. Nothing that.
Okay, let's just do an overview. Question 3, this one, right? So for question 3, I think I need to do question 2 first. I think these are related. Right, questions 2 and 3 are together. So I'll start with question 2. Okay. Can everyone see the PDF?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
See, the following pseudocode is executed using shopping bills dataset. What will A represent at the end of execution? So let's go step by step. First, D is what? An empty dictionary. Then a while loop, table 1 has more rows. Where is this table 1 from? Shopping bills. So read the first card. If not is key. Okay, first tell me. D is initially empty. First card X I have picked. Whatever is the shop name, it cannot be a part of the dictionary D because it is initially empty. So for the first card, this is key part will return what? False. Right? But what is it saying? Not is key. That means not false is what? True.
Yes.
Not of false is true. Right?
Ma'am, could
So
you
this,
please repeat it?
see, this is key part. Is key D, comma X dot shop name. I'm saying for the first iteration. First card I have picked X, and let's say the shop name is HV Stores or something. But the dictionary is initially what? Empty. No entries are there. So for the first card, this is key will return true or false. False, because there are no keys present in the dictionary currently. But if not is key, that means if not false, what is not false? True.
True.
Not of false is true. So the whole thing evaluates to true. So I will enter the if block, and dx dot shop name is one more dictionary that I'm going to create. So for that shop name of that card, I'm going to create a separate dictionary.
That
Okay.
will be FX too, sir.
Yes. So it will be D SV stores. And this is one empty dictionary I've created now. Now the next part, for each item in x.item list. Item list is what? The list of items that X has purchased. So for every such item, I'm going to take the unique item as a key of this dictionary that I just created. So let's say the first item this person has bought is, let's say, he has bought a pen. Okay. So what is the first entry?
Shop name.
SV stores. And then what is my key? Key is pen.
Pen.
And value is true.
True.
Okay, so this is the key value pair for DSV stores dictionary. Clear? Now for every item, I'm going to have this key value pair. So items are what? Unique. All items they have to be unique. So what is each shop? This SV stores, DSV stores dictionary. It is going to contain key value pairs of item is to Boolean, right? That is item is to true. Or item is to, if it is there is no provision for false, so it is always going to be true. If I enter a key value pair in this dictionary, it is always going to be item is to true. Okay. So once I'm done with all the items in this X card, I'm going to move it to table 2 and again pick the next card. Okay. So what happens if the next person is also from this same SV store? Then what will I do?
When we go to the next step,
So if the next X card that I pick, the shop name is SV stores, then is key part will return true or false?
false.
Is key part will return false.
True, ma'am.
But
True.
is key part will return true, but
already we have
overall
taken false, ma'am.
false.
Look, if I have this D dictionary, right? So this D dictionary, for the first card when I got SV stores, okay. So if I already made a dictionary out of this, that means I can say that this D dictionary has a key called SV stores because of this format. Right. So for the original D dictionary, SV stores is a key already after I got the first card. I'm sorry. What is this? First card is from SV store. If the second card is also from SV stores, do I need to create a new dictionary?
No, ma'am.
No. In that dictionary only I will add. Okay. In that DSV stores only I will add. Because in that case, this is key will then return true and not of true is false. So this will not happen. I will directly come to step 7. And for each of the items, I am going to enter more key value pairs in that DSV stores dictionary. Now, after all of the cards are exhausted, okay. Wait, let me check where are the brackets closing. This bracket is closing here. This bracket is closing here. And this while loop is closing here. So after all the cards are exhausted from shopping bills. Now in line 13, I have assigned 0 to this variable A. Now for each A in keys of D, what are the keys of D first of all?
Ma'am, shop, store, SV store and pen.
Pen is not. SV stores are what? The key. The store name is the key.
Yes.
Pen is a variable.
Okay. In D dictionary, store name is the key. Now if I say in D SV stores dictionary, then pen is a key. Okay. So for each A in keys of D is giving me a list of store names. If A is less than length of keys of DA. Okay, first let's break it down. Keys of DA. So DA. A is what? Let's say SV store is one such A. Right? So DA. Let's say for SV store, I have 10 entries in my dictionary. That is from SV store, 10 unique items have been purchased by customers. Okay. So DA will give me what? What are the keys? This pen or whatever items have been purchased, these are the keys. So what will be the length of the list? Keys of DA.
10.
The length is going to be 10 if 10 items are purchased from SV stores.
Yeah.
So if that length is greater than A, then A will be assigned the length.
Ma'am, actually, I wanted to ask something. Here, we are making different dictionaries for different store names.
Come again, your voice is cutting off.
Here, we are making different dictionaries for different stores, like for SB store, one
Yes,
dictionary for
exactly. Yes, for every store there is a separate dictionary.
and
Okay.
like this stuff they have bought, that will be the keys, right?
Yes. So the items, unique items that are bought from each store, those unique items are the keys for each of those dictionaries.
Yeah, and
Okay.
all of these stuffs will have the value 2 only, right?
Yes, the value will be true. For every entry, the value is true because true is the only value that's assigned.
Yeah.
Okay. So what is A? So tell me, what is A going to store? Look at the options. Maximum number of items sold by a shop. Maximum number of unique items sold by a shop. Maximum number of item categories sold by a shop. And maximum number of unique item categories sold by a shop. So which option do you think?
Option B.
Let's check. So answer is option B. Because we are not talking about categories, we are talking about the items themselves, right? If this is just to confuse you, because people might mistake item for item categories. Item means the actual thing that you bought. Category is what category that item belongs to. Like pen belongs to stationery, right? So the answer will be this. Now the actual question that you asked is third question. Is this much clear to everyone? Question 2, is it clear, everyone?
Yes, ma'am.
So
Yes.
here the condition in the line number 14 is always by default the A will be less than the length of the right? Length of the key.
Yeah, since it is always taking the length function for keys of DA. So DA is for every store I will have one such DA dictionary. And the length of the key, length of that is what? The list of keys, that is number of unique items present in the dictionary.
What I want to say is like no, at no condition A cannot be greater than the length of the piece.
A will no, we are not checking for that. No. A is firstly A has 0 assigned to it. So it will never initially be greater. Okay. Okay. Next, this question is the question that you asked. So it is a continuation of that one only. Consider the dictionary D we created in previous question. What will item list store? So look at the code. Item list is what? A list. Empty list I have created. L equals to keys of D. So keys of D is what?
Shop
The
name.
unique store names. Correct? All the store names are the keys of D. So for each A in L, each A is what? Each unique store name, right? So SV store is one such A. So next, when you enter the for each block, it is saying M equals to keys of DA. So M is going to be what? A list of keys of DA dictionary. Let's say A is SV stores here. Okay. So D of SV stores. What are the keys of that dictionary?
Items.
The items, unique items.
Unique items, yeah.
So all of those unique items will be stored in the form of a list in variable M. Correct? Because that's what keys function does. It returns you the keys of a dictionary in the form of a list. L is what? L is already having the list of keys of D, that is unique store names. Now L equals to rest of L. Rest of L means which element am I deleting?
First element is removed.
The A element.
First element is removed. So L now has one element removed, that is the first element. Now line 6 says for each B in L. Okay. For each B in L, that means now B is what? Again, shop name only, right?
Yeah,
But the
different
first shop name, this SV stores was let's say this is the first iteration I'm talking about. So in the outer for each block, SV stores was the first thing we picked from this list L. But in the inner for each block, before I could pick the B, I already removed SV stores, correct? By doing rest of L. Why did I do that? So that no two stores that are having the same name will be compared, right? For SV store, this will be compared with the rest of the stores. not with SV store itself. That's why I did rest of L. Because in a list, we have to do sequential traversing, right? One after another. So for each B in L, when I pick this B, will I get SV stores or no?
No.
No.
Because I have removed that
Another
in
step.
rest of L. So what am I doing in this for each block? There is again one more variable N, which has list of keys of DB. Let's say the next item in keys of D is, what was another store?
Big
Big
Bazaar.
Bazaar.
Big Bazaar.
Big
Yeah.
one.
Let's say Big Bazaar is B. Okay, that was the second item in keys D. So N equals to keys of DB. That means N is going to contain what? All the unique items that are purchased from Big Bazaar. Correct? In the form of a list. What is line 8 doing? Again, one more nested for each. So for each I in M, what is M? Keys of list of unique items from SV stores. And what is N? List of unique items from Big Bazaar. So for each I in M and each J in N, if I equals to J, then item list equals to, I will append something, this I. That means we are looking for the common items that are present in Big Bazaar and SV stores both. Okay. We are looking for those common keys between Big Bazaar and SV stores. Okay. As soon as we find a common key, that is an item that has been bought from both the stores, we are going to add it to item list. Understood? Is this
Yeah,
part clear?
understood. Yeah.
So look
Yes,
at the options. List, what are they asking? What will item list store at the end of execution? So list of items which are common to all shops. List of items which are common to 2 shops. List of items which are common to more than 2 shops. List of items which are common to at least 2 shops. Which one do you think? Look at the code carefully.
At least 2.
Option B, ma'am. Option B.
Why at least 2?
मैम क्योंकि वो इटरेशन चल रही है ना बार बार.
Because it means 2, like L and M, there are 2 lists.
So
So
it
at
has
least
to
2
be
lists.
at least 2, right? Because I'm picking from at least 2 stores. M and N are at least list of keys from 2 stores. Okay, I will keep on doing this L rest of L every time I finish the for each block and go back. But at least I am comparing between 2 stores, right? So option D will be your correct answer. So if you look at codes like this, can you now decode what each variable is storing, what the lists are storing? Is it possible for you? These are very easy codes. See, main thing that you're going to get confused is in these things. Okay. These. What are the lists storing? What is D of A? What is D of B? These things are where you will get confused, because last time also students got confused in these steps only, I saw. So just practice this type of problems one more, like more and more times. Do the PYQs, okay?
Actually, ma'am, for this particular code, we are just taking into consideration the 2 shops, right? So,
Yes. So
I'm
at a
getting
time, I am
confused.
only comparing between 2 shops. At a
So,
time, only
ma'am,
between 2
D
shops.
correct. Why like
Yes.
at least 2?
Because see, I and J, if they're present in at least Big Bazaar and SV stores, okay, if I find them common between these 2 stores, then also they'll be stored in item list. But every time I'm going back to this step, I am removing a shop name, right? So next time when I go here, I can have one more other shop name. Okay.
Yeah.
So the B will change, but the A remains same. So SV store might have same items in common with Big Bazaar as well as some other shop. But at least 2 stores should have them in common. It can be more than 2.
So it will compare the first shop with second, and then second with the third, or first with the
See,
third.
in this A is what? SV stores. With SV stores, it will compare with Big Bazaar and every other store that is there. Okay. Because this is the outer for each. And the inner for each is going to be updating every time I do L equals to rest of L.
Oh, so first with second, then first with third, first with
Yes.
fourth.
So every store with every other store. So every item that I add to item list has to be common between at least 2 stores. It can be common between more than 2 stores also. Okay. But there is no constraint that it has to be common between all the shops. As long as 2 stores have it in common, I am going to add it in. item list. That's why at least. Clear?
Yeah,
You
and
can
here
even
they
go.
here they didn't unlike the previous question, they didn't use the term categories. Else it will be the items that are belong to same categories should be added in the option, if I'm right. The last D.
No. Categories we are not checking, no? We are only
No, I'm
checking the
talking about
items.
if we have the similar situation like the previous question, I think then it will be the list of items which belong to the same category and which are common to
Yes.
the
Means
Yes.
obviously if the items are same, then the category would be the same.
Item is same, category is going to be same. But
Yeah, I'm talking about the jargons that they normally use. Sometimes different
Yes.
categories they use also.
So questions 2 and 3, this type of questions are very important for end-term exams. Okay. Quiz 2 and term both. So practice these. What is the next question you had problem in? Any other question? Or do I just randomly pick any?
Can you pick up some questions that talks about the distance part? Is it necessary or not?
See, distance part, there can be questions, but there won't be this type of complicated codes because there is no such information in that part that I can form this type of question from there. Okay. There can be questions, but they will mostly be theoretical. So mainly for that part, you just solve the activity questions. Okay. That will be enough.
Like the one that we saw, the stores example, they can't bring the distance into this kind of question.
No, it is a little difficult because it will change according to every column. No? Distance can be measured between any two columns.
That's what I was.
Yeah. So mainly you will get questions like this only that are in practice and graded. But yeah, do the activity questions for those two lectures. So let's pick up one more question. Which code looks difficult? You tell me. This one looks easy. Yeah, let's take this. This question is very important. This is very, very important.
Number 7? Yeah.
See, the following pseudocode is executed using scores dataset. Watch very carefully, okay? Because this has dictionary, nested dictionaries. So following pseudocode is executed using scores dataset. What will CTDK represent at the end? So forget about everything. Let's break down the code line by line. First line is what? CTD is empty dictionary. Second line, scores dataset. I'm picking the cards from there. If is key. That means CTD dictionary. If the first row that I picked, that student, wherever in whichever town or city that student lives, I'm checking if that town or city is a key for dictionary CTD. So initially it's going to be false, right? Because CTD is empty. Correct? So if this is false, is key will return false. Okay. Then will I be entering this nested if?
No.
No. Neither this nested if. So this whole part I will not enter. I will come to the else part here. 1 second. I think this is the wrong else. This else. Okay. How do I know this is the wrong else? Because this is the nested if and this bracket ends here. So for this if, this is the else. And for this if, this is the else. Okay. So be a little careful about this nested if else. So
Could you
if a
repeat that,
town or
please?
city.
I'm sorry,
Yeah,
could you
see,
repeat that part?
there are 3 if statements, right? So there are 2 nested ifs, this one and this one. So I'm asking which else is the else of which nested if. So since this if ends here, okay, see, bracket starts here, ends here. And for this if, the bracket starts here and ends here. So after that, the else that comes, it is the else of this if, this one.
Different block.
This is the else of this one. And this else is the else of the outer if, this one.
Can you use a different color to just?
I don't know how to change the color of.
Okay.
Erase all.
Okay. Let's just erase this. See, for this if, this is the else. Okay. And for this if, this is the else. Now, okay?
Yeah.
It seems like a straight line will help more. Huh? A straight line of if to else.
Okay. See, this.
The block.
And this. Right? Now let's solve it. So for the first town city, let's say the card that I picked, the first town or city in that card is Kolkata. Fine. So Kolkata is not a key of this CTD dictionary, which is initially empty. So where will I go? I will come to this else, correct? The outer else, because I'm not even entering the nested if, right? Since this condition is false, it is not a key. So I will create a key in CTD dictionary for Kolkata. What is it doing? It is actually creating another dictionary for Kolkata. So CTD Kolkata is now the dictionary, which is empty, and within that, I am again creating now the key value pair. So whatever is the gender of the student in the card that I picked, let's say it's a girl. So gender is F. So CTD Kolkata, female, and I will assign the physics marks scored by that student as the value. So tell me, for every different city, there will be a separate CTD dictionary, CTD town city dictionary for every unique city, correct?
Yes, ma'am.
And for each of those cities, there will be two different key value pairs, one for female, one for male, right?
Yes, ma'am.
Now, this much is clear, everyone. Now see, next card that I picked. Let's say the next card that I pick is also a student from Kolkata again. And that person is also female. Then what happens? If is key CTD Kolkata. So this is true now because I already have an entry for Kolkata. So I will go to the nested if. Is key CTD town city. That means CTD Kolkata, this dictionary that I just created. For that, now I am checking is the gender, that is female, a key.
True.
For the last one, I created it, the key value pair. So it is a key. So this will return true. I think people got confused in this step, right? See.
No, ma'am. No, ma'am.
No, ma'am.
I will just write it down still for. So I created this in the last step. This is the dictionary, and what is the key value pair present? F is to, let's say the physics marks, this code is 80. This is present now. Okay.
Yes, ma'am.
Now the second card I picked is also from Kolkata, also of a girl. So this first nested if, this first if is satisfied, even the nested if is satisfied. So I will now go to this if. Okay.
Yes, ma'am.
So city D, Kolkata, female. For that, I am checking, what was it? Previously 80. Is 80 less than the current card's physics marks? If this person has scored 90, the current card. So is 80 less than 90? Yes.
Yes, ma'am.
If yes, then I'm going to update the marks with the higher marks. So basically, what is the code doing for every city? It is finding the highest marks scored in physics by both male and female students. Correct?
Yes, ma'am.
That is the dictionary. That is what the dictionary is storing. So each key value pair is what? For every unique city, I have two keys, one for male, one for female, and the keys themselves have corresponding values that are the highest physics marks scored by males and scored by females from that city. Clear? So now the question is asking, what will CTDK represent? So what is CTD Kolkata representing?
Representing
A
the
dictionary with, let's see, what are the options? A dictionary with gender as key mapped to the physics marks. A dictionary with gender as key mapped to highest physics marks scored by that gender in city K. A dictionary with gender as key mapped to lowest physics marks. I can already ignore this because definitely not lowest. I'm checking for whether it is higher or not. Right. And a dictionary with cities as keys mapped to physics marks. So which option?
B.
B.
B option, let's check. Yes, answer is B. So, clear everyone, this code? Any problem?
Here, we are just comparing like male marks to male marks only, not to the female marks, right?
Right. So that's why I have this
That's
gender
why
key.
B
Na?
is.
Yeah. Male only with male, female only with female. No interconnection is there.
Ma'am,
Okay.
here the unique key is gender, right?
Yes. Here for every city there are only two keys. One male, one female. Okay. For Kolkata, there is one key male, one key female. And the male key is going to have the corresponding value of the highest physics marks obtained by male students in Kolkata. Similarly, for female, it will be highest physics marks obtained by female students in Kolkata. Understood?
Got it.
So this question, this type of question has been asked many times. This exact question only. Okay. So it is very important. If you are able to solve this type of problems, you will be fine in your in terms of quiz 2 also.
Okay, ma'am.
Okay. Next, which question should I take? This one?
The 10, you can start with 10, but also prefer 8 and 9 if you have time.
Sorry, come again.
Question number 10, the last one. And if you can extend, please solve
Yeah,
8.
sure. I don't have a problem. Yeah, I will solve the 10th question. This one, right?
Yeah.
Okay, let's see what this is doing. Just 1 second. Okay, I'll get some water. Yeah. Is this a part question or just a single one?
Single.
Okay. Read the statement. The following pseudocode is executed again on scores dataset only. Let M, P, and C be lists of sequence numbers of students who have scored more than 80 marks in maths, physics, and chemistry respectively. So M is a variable that will store a list of sequence numbers of cards of those students who have scored greater than 80 in maths. Similarly, for physics and chemistry, I have 2 other lists. Okay. At the end of execution, dict80 stores a dictionary with the sequence number of student mapped to the number of subjects in which the student has scored more than 80 marks. So at the end of execution, I want to have this dictionary called dict80. It will store what? It will store the sequence number of the student. That means sequence number of the student will be the key of this dictionary, right? And it will be mapped to what? That is, what will be the value that it is mapped to? Number of subjects in which the student has scored more than 80 marks. So choose the correct implementation of the N sub procedure. This is an MSQ, so be careful. You have to check all of the options. So firstly, this part of the code is given. Dict80 is an empty dictionary. While table 1 has more rows, read the first row. Dict80 sequence number. Okay. That means for every sequence number, every card, every student's card, I will do this procedure, N sub X sequence number. So what is this doing? Mainly this part. So the job of this part is to find out the number of subjects in which this student with this sequence number has scored greater than 80, right? So let's check the first one. Procedure N sub N. First, N is what? The sequence number of the student, right?
Yes, ma'am.
That's the argument. Now, count is a variable I have assigned as 0. If member M, small n. Member is nothing but that is key function. Okay. So, I'm sorry. Member is a list function here, right? That means if n, this sequence number, if it is a member of this M list, that means what is M list? Sequence number of those students who have scored greater than 80 in math, right? So the sequence number of this student for whom I'm checking, if that sequence number is a member of the list M, then I have to increment count by 1. Okay. Then again check if that sequence number is a member of the list P, that is for physics marks. If they have scored greater than 80 in physics, then again increment count by 1. And for chemistry also check the same. If true, then increment count by 1. So what is the maximum value that count can have for a student?
3.
3.
What does that mean? That that student has scored greater than 80 in all 3 subjects?
All 3 subjects.
And then return count. So is this procedure fine?
Yeah.
Yes.
So this should be one of the answers. Okay. Now check the second one. Procedure. So everything is same until this step. If count is greater than 2, return true. Otherwise, return false. Okay. So this is saying I want to find, my goal is that I want to find for each sequence number the number of subjects in which he has scored more than 80. He or she has scored more than 80. I don't have any constraint that it has to be more than 2 subjects in which he has or she has scored more than 80, right? So there is no
Yes.
such constraint that count has to be greater than equal to 2. Right? So this is not required. That means this code is wrong. Right?
Yes, ma'am.
Because it will even return false even when count is 3. I'm sorry, even when count is 1, it will return false. But it shouldn't return false. It should return the actual count value. Right? I don't want Boolean return value. I want the actual count. How many subjects he has scored greater than 18. So this option is wrong. Option C, now check. N sub is now a dictionary. While table 1 has more rows, read the first row X from table 1. Now count is 0. If that sequence number of the person, okay, see, N sub is a dictionary now, okay, it is not a procedure. Understood? In these two other options, it was a procedure, right? See, procedure N sub. But right now it is what? It is a dictionary. So first I am going to take all of the cards from table 1. Now every time I pick up a card, count is initialized to 0. Again, I check if that sequence number of that card is a member of list M. If true, increment count by 1. Similarly, for physics and chemistry, also check. If true, increment count. Now it is again checking if count is greater than equal to 2. Then only N sub sequence number will have the value true assigned to it. N sub sequence number is what? Sequence number is here the key for the N sub dictionary, right? Because sequence number is unique. But it is saying only those sequence numbers will have the corresponding value true where the subject count in which they have scored greater than 80 is greater than equal to 2. But is there any such constraint given in the question?
No.
No, ma'am.
No.
So this is wrong. I think option D is the same without this part. So in option D, we are going to fill the dictionary N sub with key value pairs like sequence number is to count. That is sequence number of the student is to number of subjects in which he has scored greater than 80. Right? So this option is correct.
But it won't be correct because it is a call procedure and this is a while step.
Dictionary.
It is a call procedure.
It is doing what? 80 x sequence number equals to n subsequence number. Okay, so this is calling a procedure.
Yeah, but that is not a procedure. So
That
it
is
won't.
why this one will not be answer. Why? This is a dictionary, it's not a procedure. That's why I told you that in option C and D it is a dictionary, but A and B it's a procedure. How do I know it's a procedure call? Because here in sub, this parameter is passed in what? Parenthesis. Right? If this, now I'm just telling you, for example, if this n sub, instead of parenthesis, if I put it in this, then what will happen? Then which option will be correct?
The last D.
Then option D will be correct. Because then it is not a procedure call. It is trying to find the corresponding value of the sequence number in N sub dictionary. Understood? But since it is in...
Can we call a dictionary also? Yeah.
That's what I'm saying. If this was written, then option D is correct. But it is not written. It is given, the argument sequence number is passed in a parenthesis. So we know that this is a procedure call. This is not a dictionary. Right? So only option 1 or option A is true, even though it is an MSQ. So be very careful. Actually, I remember that a lot of people got this wrong. This type of a question came in previous years also. So they also marked this last option correct. So it's very good that you already know the difference between this dictionary and procedure call. So just be careful when you do these MSQs, okay? Only option A is the answer. Fine?
Okay, ma'am.
So you've solved this entire practice problem assignment, all of these, okay? All the problems, don't leave anything. And then attempt your graded. If you have any issues, you can always post them on Discourse or Google Forum.
I have a question here. When the current question that you solved, the 10th one, where all the 4 options can become wrong.
All 4 options will be wrong.
When will be the state? Like based on the now you said mentioned about the procedure in the dictionary. Based on the same thing, like in the for the 6 lines, where you can take a call where all the 4 options can be wrong.
Currently, I cannot tell you if there is any such thing that I can say that all of these will be wrong. Why I said that this can be wrong is because procedure and dictionary are two different things. So in that way, I can eliminate 2 options just by looking at the options, because I need a procedure call. So I don't even actually have to evaluate options C and D because there is no procedure call defined here. Okay.
No, because
So
it's
just
always
looking at the, it's
sorry.
not always going to be like this, right? So that depends on your question requirement, whatever is given in the question.
Because it's always the case that we
So
find in the MSQ that no error will be the option. But is there a way that we will come across, or I haven't come across,
see,
saying that there is an error, all are error kind of thing?
yeah, that can also happen. So the main thing in this type of, like, what smart students will do is they will look at this code and instantly they can eliminate options C and D. Okay, they won't even waste their time on that. Just check for options A and B because only there the procedure call is defined. Right.
Can you read the statement question? It clearly says identify the procedure for N sub implementation.
Yes.
So it has
Correct.
to be
No. See, it is written choose the correct implementation of N sub. It is not said whether N sub is a procedure or a dictionary.
Yeah, that's correct.
Okay, that you have to identify from here, because in a dictionary, in the keys, whenever we are trying to find the value, we put it in third brackets. Since it is in parentheses, that means it's a procedure call. Okay. All right. So you solve the rest of the questions. Any problem, you can let me know. Okay. That's it for week 7. So please submit your graded by Wednesday, everyone.
Then solutions of week
Okay.
5 and week 6 graded assignment are not uploaded yet.
Graded assignment, you have queries from weeks 5 and 6.
No. The week 5 and week 6 graded assignment solutions are not uploaded.
Solutions are not updated. Okay. I'll let the team know. Okay.
Excuse me, ma'am.
Yeah.
Ma'am, actually, I had a doubt regarding a assignment 630 that was returned to us few days ago. Could I ask that, please? There was just one question that I wanted to resolve.
Which one? Assignment 6 graded?
Yes, ma'am. Graded assignment 6. It was question number 4, I believe. I believe that the options were a little incorrect.
Okay, question 4. Actually, I have a little bit of a problem. I cannot extend this any further, but can you do one thing? You know my mail ID, right? Just send me the question there once. I will check and get back to you.
Thank you, ma'am. Thank you so much.
Yeah. You have my mail, right? Or discourse also. Anywhere you can do that.
I could look it up. That's fine.
Yeah,
Okay.
just send me the question. I will let you know if it is wrong.
I have basic query. If there are error with the graded assignment question, like the final term, like the Q1, we will get additional marks in the J also.
Yeah, if the error is on our side, then definitely marks will be given to all. If you have attempted the question, you'll get marks. Okay. All right, everyone. Thank you for joining. Next class is on Friday, as usual. Okay. Thanks. Have a good night.
Thank you, ma'am.
Thank you.
Thank you.